The gold team's project for RockSat is to use a GPS receiver that we have purchased and built and compare the data to camera imaging that tracks the coastline as it's going up in the rocket, hopefully compare the two telemetries of the rocket. My job, I'm the principal investigator and project manager for the gold team. My job is to make sure that we follow all of the user guide compliances that Wallops puts forth for our experiment, and to make sure that we stay on track. Budget, personnel, timing, schedule, everything else.
So I'm on the camera team and I'm a software person. So I'm developing a code for image post-processing. So basically I would just take the images that we collect from the GoPro and compare them to other satellite images that we found to see like what matches with each other.
So I am a instrument lead on the camera team. I helped decide what camera we're going to fly.
I helped choose the GPS receiver we were going to fly and design the integration of this part into the canister itself, and as well as working with their antenna, choosing which antenna, how that was going to connect to the splitter and then to the receiver.
I'm a mechanical member working primarily with Gold Team and primarily focused on developing a cantilever system to optimize the field of view for our coastal mapping project. A cantilever is a simply supported beam, just simply anchored to one point, allowing a load or something to be suspended from the other end.
Well, at first I was the C and DH guy, but as the project went on, all of our jobs kind of got mixed together and everybody was doing everything. But mostly I worked with the camera team to get the GoPro running.
So I started out doing the software for the GPS subsystem, but as the project progressed, we moved towards a more generalized role where we just tested the system with all the components. So software was more on the data collection and afterwards processing the data to get the GPS solution from the receiver. Generalized role was more geared towards testing and getting the actual results the way we wanted it to.
I'm an instrument lead on this project, which means that I am basically one of the people that's in charge of organizing the people working on the GPS, as well as doing a lot of the work on it myself, such as running tests, organizing people to find out what sort of connectors, how to hook it up to the rest of the systems that we have on the mission, things like that. Well, we had to run it with a few different antennas for one thing to see what sort of environment the antennas worked in the best. We had to make sure that the antennas would be able to receive signal consistently at all times and make sure that the GPS was properly powered. We also had to make sure that signal was getting split properly with another mission that needed its information.
So Blue Team's project can be broken into 4 different sub-projects. So first there's the magnetic field sensor and the Geiger counter to sense radiation. So the purpose of these experiments is to compare the radiation and magnetic field that we sense during the experiment to models that we know exist. So we have an IMU paired with a microcontroller, takes data from the IMU and stores it for later analysis. So the IMU is the inertial measurement unit, and it has gyroscopes and magnetometers and other devices that allow it to determine when it's being accelerated in a direction. Then the fourth one is using an SDR, software-defined radio, as a GPS.
My job is to work on the Blue Team as their mechanical engineer. A mechanical engineer is the person who talks to each of the systems engineers and figures out their weight requirements, their size requirements, what they need in terms of mechanical interference, and we try to place everything in the spacecraft where it'll fit.
My job is to develop PCBs for the INS team, and I also worked on doing we integrated in a power distribution board on that too. So that involved a lot of soldering and putting pieces together onto a PCB that we developed. INS is an inertial navigation system, and we use an IMU, which is a device that can measure the acceleration to let us know what our position is based off where we were.
I am one of the mechanical design leads here on the RockSat-C project. So primarily I work with the CAD design and building up of the canister itself. So the main part.
I am the instrument lead for the signal-defined radio. So the signal-defined radio is a piece of hardware, and essentially what you can do is tune into any radio frequency. And so the GPS satellites have a certain radio frequency, and we can tune into that and use this front end as sort of a like GPS positioning system. That's a lot cheaper than a standard off-the-shelf processor.
So I handle all of the system integration for the various experiments coming together and working together in the payload.
Alright, I work on the magnetometer and radiation team as well as the INS. I work with trying to figure out how the magnetic field around the Earth works, as well as finding radiation as we go up into the atmosphere and come back down, how that changes, and kind of looking at the variation there, maybe using it as a possible source of attitude determination. With INS, we work on trying to work with the GPS to try and figure out an exact attitude at that point.
Okay, I work on software for the inertial navigation system.
I'm the magnetometer lead. I'm responsible for all the instruments involved with the magnetometer experiment and just kind of everything that surrounds the software and stuff like that.
My favorite part of the project was understanding that you can get into things that you don't know anything about and come out like ahead. You can actually work with what you know, what you want to learn, and put it together for something advantageous.
I think the idea of just problem solving and, you've got this that you need to fix before X date is going to be something that you're always going to have. So I think it's going to be something that's really useful just to kind of get the idea of you've got a problem, solve it, and you have to figure out multiple different ways because it's kind of something that's really important, really sensitive. So I think it'll be something that's been, at least the idea and the experience behind it will help later on.
It's at a good pace, and you get what you put in. So if you want to work, that's really helpful, and you'll get a lot out of it. Yeah.
It was a really memorable experience. I've actually used this experience in like a couple job interviews as a project experience that I've had. And I definitely talked about it in getting the job that I have now. So I think it was a good, memorable, and valuable experience that I could use.
I think it'd be very useful in the future. I think no matter what career path you choose, you're going to have some sort of leadership and team building experience, and all of that experience gained throughout this class will definitely help through future endeavors.
This is, it's a very hands-on project, and, this is what engineering is. We kind of had an open-ended question where we had to, make our own solution for, and that's basically what engineering is in the industry. You're not given a question or a problem that already has a solution. You got to figure one out yourself, and this was what this whole project was about.